Welcome to the QueBIT presentation, Embedding Artificial Intelligence and Machine Learning in Supply Chain Planning. This presentation is about making machine learning, artificial intelligence, predictive analytics, or advanced analytics easy, or how QueBIT can help you make it easy. In this presentation, we will use advanced analytics as a catchphrase to refer to any of these predictive models. We'll be talking about planning and forecasting, but these concepts apply to optimizing production, supply, capacity, logistics, and inventory, in general, all things supply chain. Plans are useless, but planning is indispensable. Eisenhower was referring to, in an emergency, he went on, the first thing to do is to take all the plans off the top shelf and throw them out the window. But if you haven't been planning, you can't start to work, intelligently at least, he said. Never more appropriate than now. How accurate and executable are the annual plans you created late last year? The details of a plan, which was designed months or in these times days in advance, are often incorrect. But the planning process demands the thorough exploration of options and contingencies. The knowledge gained during this probing is crucial to the selection of the appropriate actions as future events unfold. It's really about the ability to understand why things are happening, compressing the planning process, iterating, and being agile. Quick planning to be able to react to events and trends as they happen. And planning is indispensable. In thinking about why planning is indispensable, a recent executive survey outlined 5 areas that drive planning: visibility, cost containment, risk, customer intimacy, and globalization. The amount of data continues to increase, yet we all still struggle to act on the right information. In this age of pandemic, cost containment, risk, and globalization in the supply chain are more important than ever. Getting close to the customer is a mantra, and our demand planning example will help illustrate how to help us move in the right direction. All these issues are continuing to come faster and faster. It's imperative we find ways to quickly plan and infuse agility into the planning process. How are advanced analytics best used to help your supply chain? Now that's a good question. It's a tool for data and data science. Part of this science is developing the logic, the process, and the framework to apply to any problem. It starts with a great question, and it's tied to measurable outcomes. It often includes both numbers and directions. The reason this is important, we're doing planning all over the organization. Performing planning with better accuracy and more quickly by embedding advanced analytics produces a ripple effect, a good wave across the organization. Demand planning at the center, and it feeds production, supply, inventory, and the operational revenue plans, and subsequently to the financial plans of the organization, creating an integrated business planning process. We will use an example of embedding advanced analytics and demand planning as an example of how to drive automation in this integrated business planning process. Advanced analytics is all the rage. If you believe some sources, we are on the precipice of a day when everyday citizen scientists will be capable of generating endless streams of predictions. This, of course, promises to change the world. Or is it a ridiculous pipe dream that woefully overpromises a large volume of outcomes that have little practical value? So let's talk a little bit about some of these advanced analytics misnomers, challenges, and possible solutions. The first one being expertise. Expertise is a challenge because advanced analytic solutions are typically designed by and for data scientists who have a deep understanding of statistical modeling. This is inherently limiting. In fact, most application teams can't even begin to approach advanced analytics without first hiring a dedicated data scientist or contracting with expertise like QueBIT provides. The solution? Fortunately, you don't have to settle for a limiting solution. Today, new predictive analytics solutions are emerging and they're designed for almost everyone to use. The second challenge, or misnomer, is adoption. It's not a secret that the more difficult a new technology is to use, the less likely end users are to adopt it. And advanced analytic solutions are notoriously difficult in meeting this challenge. This is because they typically live as standalone tools, which means users have to switch from their primary business application over to the analytics solution in order to use it. What's more, traditional advanced analytic tools are hard to scale and deploy, which makes updating them a painful process. The solution for adoption is that advanced analytics are most effective when embedded inside applications people already rely on. Embedding advanced analytic inside your application gives you a huge strategic advantage over the competition and gives your end users a strategic advantage for their business process and planning. And the third area of challenge is around empowering end users. No information is valuable in a vacuum. And that's one of the reasons advanced analytics have fallen short in empowering end users. Often tools deliver information and insights, but they fail to let users take action. As we discussed above, if users want to act on the data, they have to jump to yet another application, ultimately wasting time and interrupting their workflow. The solution is by embedding intelligence into your workflows and into your regular business applications, you'll empower your users to take immediate action or trigger another process, saving them a lot of time and frustration. It's called data science for a reason. It's not magic. Every predictive analytics project requires an extensive list of steps, which are almost always handled by a dedicated data scientist or a data science-driven team like QueBIT. The challenge is that for every update and release, these steps place more of a burden on your application team. Some of the steps include things like data prep, data cleansing, identifying important fields in the data, recognizing correlations, as we'll go into, understanding how different algorithms or the math work, choosing the right algorithm for the right problem, deciding on the right properties for the algorithm, ensuring that the data format is correct, understanding the output of the algorithm run, retraining the algorithm with new data, dealing with imbalanced data, deploying or redeploying the model, predicting in real time or on a batch basis, and then integrating with your primary application to build data insights into that application and initiate user action, embedding predictive or embedding advanced analytics. So what's the journey to easily embed advanced analytics into your organization? We've inserted this maturity map to help you understand and benchmark yourself and your organization. There's not a right or wrong place to be on this curve. It helps you determine your level of forecasting maturity and how you can start thinking about how you evolve your forecasting process. Level 1 is by far the most common state we see organizations. Derived assumptions, lots of human bias. There will always be some subset of this at any level of maturity. In times of high volatility like now, this may be the only way to forecast. Level 2 runs a model at a more summarized level, say by quarter, by business unit level. Then you move to level 3, which is a consistent way to engage analytics on historical internal data at a monthly or weekly level. And then on to level 4 adds a higher level of sophistication, including historical, and introduces external data like product or customer attributes, demographics, climate, pertinent macroeconomic variables. And we'll take you through an example of this method. And then level 5 incorporates the internal and external, but now you engage them dynamically in your applications to perform quick, iterative plans. So let's go take a look at an example. This will all be about how to make this process easy. It's about sourcing the data, breaking down data silos, automating the collection process, identifying the variables, and then embedding advanced analytics in the planning process. Getting closer to the customer. One of our planning imperatives that we outlined above is about understanding how customers come to you. So we start with historical data, internally sourced from a customer's ERP or a QueBIT contracted sales data mart, as we've done here and shown in lines 1 and 2. Sales by location, and how well does this product turnover relative to other locations. There are important variables outside of the historical data that are highly correlated. Vehicles in operation by make and model. No need to stock a lot of foreign car parts in an area that is highly saturated with domestic vehicles. Sales of vehicles in areas adjacent to your locations, and climate for the regions close to your locations. You can see we are pulling from several different public data sources and some QueBIT proprietary data. This is about identifying those internal and external predictors that have a material impact on the planning process, in this case demand planning. This could easily be applied to supply or production forecasting. The most important consideration is having a platform that can source the data and the data scientist team that can validate these external data sources and marry them with your historical data. So let's dive into how QueBIT plays a valuable part in this process. For example, vehicles in operation. The raw data may not be in a format for easy use. Data scientists play an important part in prepping this data by groups or attributes to be able to use them in the forecasting process, grouping them in logical buckets that can be used to feed the models. An example would be vehicles in operation. We bucketed the data to help drive the model. In this highlighted line, we group vehicles by age. Younger vehicles have less major component failures, but are a market we could target for general maintenance or wear and tear parts, brakes, rotors, windshield wipers, etc. Whereas grouping older vehicles, if you have a higher population of this group of vehicles, the store's assortment should support these major components that tend to fail in these senior autos. So it's about understanding the data and inputs that form the basis for external variables and their inclusion in the advanced analytic models. How do we evaluate the usefulness of any of these variables? Evaluate the inputs against historical data to find out if they have any correlation significance. In this example of a particular part, we can see that percentage of sales within a geographic area, the auto platform, and climate are the top 3 predictors of importance for predicting demand for this part. With this customer, there were more than 200 variables fed into the model and evaluated to determine which are the most important by product or product location combination. Modeling at this lower level is needed because the impacts of the variables are different across each individual part. Let's take a look. So the variables in the rows are mapped to product categories and down to the product level to determine the weighting to expect. As you can see for rotors, vehicle count is by far the most important predictor, while ignition coils are more driven by the part's age or life cycle, and to a lesser degree the vehicle brand. You have to be able to bring variables in an automated and efficient way, then let the system calculate the relationship, assign the weightings, and reassign as the model continues to learn and grow. So it's dynamic, it continues to learn. So how do we use these drivers to then interact and embed in our applications? Why are the application of external variables important? Well, it helps you get to the level 5 in your maturity journey. Well, yes, but let's take a look at a screenshot from a QueBIT Galileo demand application to illustrate the value. You can see we're using a couple of variables like types of ad spend and the promotion type to affect the demand signal. And engaging these variables in the planning process, we can see they are planning rotor unit demand by week, and in addition to using the baseline historical predicted value, they're engaging digital and print ad spend and scan down or end cap promotions to drive additional volume. Entering these drivers, clicking on Rerun the Forecast, which calls the QueBIT predictive engine, then recalculates and immediately returns a mathematically based forecast. This is where you can really start to harness the power of your data, harness the power of advanced analytics, embed it, and take your planning to a new level. You'll be able to quickly generate multiple scenarios, engage levers that are based on significantly weighted variables, and make investments that will move the needle, whether that is a demand or supply model. It's important that any system or provider provides you with this type of flexibility and depth in the planning models. Let's dive into some customer success. Let's talk about ROI and outcomes. Hard dollar ROI is primarily driven by forecast accuracy improvements. We will discuss how to present the case for forecast accuracy improvements in a hard ROI business case. We will also discuss how your ROI in process improvements are realized by these advanced analytical methods. Safelite Group, with over 6,000 locations, with many of them mobile, wanted to raise the level of their forecast accuracy. They were mired in a manually driven process that only allowed them to plan at a category level on a monthly basis. This level didn't allow them to turn plans into execution. Execution is very important to drive profitability due to the nature of Autoglass, fragility, customizations like tints and sensors, and the bulkiness of the product. Top-down analysis of over 30 variables and spreading of the forecast down wasn't cutting it, as it was highly inefficient. QueBIT extracted their variables, much like we've discussed prior, and determined the most effective, which boiled down to 3 drivers, and automated this forecast. The result was removing 40% of their process time from their rolling monthly process and removing 60% of the process times for their annual process, all while significantly increasing their forecast accuracy at a SKU location level. Now Safelite is able to quickly run scenarios with these identified key drivers, one of which is weather. But it's not about predicting weather. It's taking how much precipitation, days above freezing, cold or warmer winter predictions, and including them in the model to drive demand forecasts. Assigning weights to the variables help drive forecast accuracy, efficiencies in the planning process, and decisions on where and what to make investments in. We're going to discuss two forms of ROI we see in these type of projects. The first one being improved forecast accuracy. With improved forecast accuracy, we typically drive these type of metrics, which are fairly easy to measure and determine your return. Shorter cycle times from a customer service KPIs, improved on-time deliveries, supply chain KPIs like reduced inventory, efficient production scheduling, and business KPIs like cost avoidance, getting the right product in the right place at the right time the first time, better inventory strategies, improved efficiency and program execution. Some of those type of measurements are harder to drive a hard ROI. But let's take a look at an example business case for improved forecasting. This study comes out of a Gartner study called Win the Business Case for Investment to Improve Forecast Accuracy. And their study showed that for every 1% forecast accuracy improvement, you typically see a 7% reduction in inventory, a 9% reduction in inventory obsolescence, and a 2% reduction in transportation costs. So taking this is an example of taking, say, $100 million worth of inventory. At a 7% reduction is $7 million in reduction. Looking at it on an inventory carrying cost basis at, say, 5%, that's a $350,000 improvement. And if you can improve that by 15%, so every 1% improvement, we're going to say it's a 15% improvement in forecast accuracy, that alone looks to drive around $5.2 million a year in savings. And then you can start looking at other things like inventory obsolescence, applying these same sort of calculations. QueBIT provides these types of studies at no charge. We can help you drive a business case and prepare a presentation for leadership. So those are some of the hard numbers we can prove. The other side of automating the planning process is the gains in planning efficiency, organizational agility, and driving down process times. Data loads, transformations of data, and running the forecasts are all now automated activities, freeing up your analyst time to perform analysis. So how do you quantify some of these gains? Well, a non-traditional approach to the ROI is needed. Rarely do we see clients reduce staff. It's about higher value added activities. Look for ways to optimize demand and supply plans with the time reduction through automation. It's about the ability to reduce the amount of time it takes to understand, plan, and execute. Proactive recommendations and reduced latency in the decision process are invaluable. But to capture this value, you must capture stories from the trenches. Document your successes and spread the word to leadership will help support these types of projects. If you are seeing some of these operational outcomes, you are experiencing a positive ROI. Let's discuss one of our other customers, a large global manufacturer. It's about automation. QueBIT spent time breaking down data silos and cultural silos in their planning process. Disparate ERPs, inconsistencies in definitions. In other words, some planners considered orders as actuals, while others used shipments as actuals. Getting them on the same page was key. For demand and supply planners, passing spreadsheets, debating accuracy, and consensus reaching was a 2-week process, then subsequently distributed the plan to 20 other planners that spent another 2 weeks, and then subsequently passed it on to finance for final review. This whole process that was over 4 weeks is now performed through automation and advanced analytics. Analysis now happens rather than data manipulation and manual entries. So we started this presentation with a review of why planning is indispensable, a review of the advanced analytics methodology QueBIT employs, a review of how to build an ROI-based business case, and a couple of great customer success stories. So to wrap this up, let's review how QueBIT can ease your advanced analytics journey and help you move up the maturity curve. We've been very successful in planning. We've been a virtual planning and analytics organization for 20 plus years. This is not something new to us. We have material customer success across integrated business planning, demand, supply, capacity, and replenishment planning projects. We have extensive data science and supply chain planning expertise on staff, with best-in-class analytical applications that cover demand, supply planning, price optimization, assortment planning, and many other areas. We also have a significant amount of IP in forecast modeling and deployment of those models. We do some very interesting thing around automated seasonality detection, stripping out trending independent of seasonality, and then combining them back together to evaluate and apply all possible time series lags to these models. We then provide advanced outlier detection, which can be very important in providing accurate forecasts. We identify and incorporate causal predictors as we've outlined and shown. And it's not a black box. Users have the ability to enhance base models, to interact with those base models while they're in the application or the planning process, really making it your journey easy with QueBIT. Thank you for your time today.